Today I'm looking at leaf similar trees. We're going to consider the leaves of a binary tree. From left to right order, the values of those leaves form a leaf value sequence. So the sequence is 6, 7, 4, 9, 8. And we essentially want to check if two trees have the same sequence. So are they the same? Do they have the same sequence? So 6, 7, 4, 9, 8. 6, 7, 4, 9, 8. These trees are, say it with me, leaf similar. And these trees are not. They're 2, 3, and then 3, 2. And so I have some pseudocode. So what are we going to do? We're going to, so we can do this with an array. So we're going to use an array to store the sequence. And storing them in an array for both binary trees allows us to easily compare the values. And how are we going to explore the trees to even get these? Well, we're going to do that inside of a getLeaves function. And we're going to set the array equal to the getLeaves function, which is going to basically clean it up so we don't we have the functionality of getting the leaves tied up inside a little compartment, and that makes the code clean code. And so once we have returned arrays with the sequence, we can first off, if the size of both are different, then that means of course it's false, return false. Because if they have different sizes, then they are definitely not similar. And then we have a for loop for values in array 1 and 2. If even one of those values is different, return false. And then outside of the for loop, we're going to want to return true. And so you might be asking, okay, but where's the pseudocode for getLeaves? Well, I'm just going to say it. So getLeaves, it's going to take a node, and inside of getLeaves, we're going to have an array called leaves, and then we're going to have a stack array, which is going to take a node. And so the stack array is where we're going to add our elements that we want to process. And then we're going to use a while loop that's going to continue while there are stuff in the stack. And then we'll have a variable for current, which basically will pop stuff off the stack, store it in current, and then current will store the nodes, so the individual nodes, so we can check if there's a left and a right and add them to the stack. And then after we do that, we can we have no problems. We can check if it's a leaf, and if it's not a leaf, we can add its children to the stack, and that's what we're going to do. So let's go. Okay, initialize an array. Const leaves 1 for the first binary tree. Let's imagine we're doing this tree. Okay. So we're going to initialize the binary tree, set it equal to our getLeaves function. The getLeaves function is going to take root 1 and for the other one, leaves 2, root 2. And essentially, if the lengths are different, so leaves 1.length does not equal leaves 2.length, return false. Okay. And then for the numbers in both arrays, we can iterate with indices and use those indices to compare values from within both arrays. So, and theoretically they're going to be the same size, so leaves 1.length should be fine. I++, and open those curlies. Okay, so if at any point they do not equal each other, then it's not any good. Return false. Otherwise, if we want to do this outside of the for loop, return true. Now why? Why? Because we want to look at all the numbers before returning true. So we're not going to do if else or something like that. Now, what is this get leaves function I've been hearing so much about? So essentially, we're going to use a stack. So first off, this is separate this stuff. That way it doesn't get confusing. Function get leaves, and it's going to take a node. And so we're calling this function for both leaves 1 and leaves 2, the different trees. The different trees. Imagine if we called them trees instead of trees. That'd be a different world. Far inferior to our world, or superior, I don't know. I don't live there. And so we're going to store them in an array, const leaves, because we're going to be returning an array to our leaves 1 and leaves 2 array. And so they're going to be a generic leaves array. And we want to initialize the stack with the first node, const stack equals node. And that's going to basically start with the head node, so starting at 3, hypothetically. And we're going to stop. We're going to stop exploring the tree when the stack is empty. And as we explore the tree, we're just going to be adding nodes to be processed. And so the current is going to be current equals, it's going to be popped off the stack. So stack.pop, and that's going to be the current. And notice how it's iterative, or it's inside the scope of the while loop. So essentially that means this is going to change every time. So we're going to, each iteration when we come back here to the current. And if we have a current, then we want to see if it's a leaf. So if it's a leaf, we said that it means it doesn't have a left or right child. And so it's the extremity, it's the last one. It's as far as you can go without going any farther. So if it's null, so if not current dot left, if current does not have a left, as well as not current dot right, so there's nothing there, then we're going to push it onto our generic array leaves, push current dot value, and then so if it's the extreme, so if we found a leaf, then this is do if it's a leaf. Do if we can keep going. So if we can keep going, what are we doing? We're going to look left and we're going to look right. So we're going to add left and right and process those. So we're going to add them to the stack. So if current dot right, then stack dot push current dot right. And we'll do the same thing for the left side. Bada bing, bada boom. Very good. Here we go. Okay. So we keep going, and then we have stuff in the stack, and it'll pop it off. And go left or right, and if it's a leaf, it gets pushed on. And that's essentially it. Yeah. Leaves one.length. Cannot read properties of undefined reading length. We did not return anything in our helper function. Return leaves. So if it's undefined, it means there's nothing there at all. And so you gotta return stuff.